Students, today we are going to discuss about nucleophiles and electrophiles. So nucleophiles are reagent that has high affinity for electropositive centers. They possess an atom has an unshared pair of electrons. Okay, for example, I'm going to write here nitrogen has lone pair of electrons. Okay, that is the two electrons are unshared electrons, that is unshared pair of electrons. So this species is called nucleophile. So, and some species have negatively charged, for example Cl minus, OH minus and O minus or COO minus. These species having negatively charged. So negatively charged species have unshared pair of electrons. So these species are called nucleophiles. So nucleophiles are two types. One is neutral nucleophiles and negatively charged nucleophiles. Okay, neutral nucleophiles are neutral molecules having unshared pair of electrons. For example, ammonia. In ammonia, nitrogen has lone pair of electrons, that is unshared pair of electrons. Similarly, amines also have nitrogen has two electrons, that is unshared pair of electrons. And in water, alcohol and ether, oxygen is the electron rich site. So oxygen has lone pair of electrons, that is two lone pair of electrons in water, alcohol and ether. Similarly, hydrogen sulfide, thiol or thioalcohol, sulfur has two lone pair of electrons. So it means electron rich center. So these species are called neutral nucleophiles. Now we are going to discuss about negatively charged nucleophiles. First one is fluoride, chloride, bromide and iodide. So generally halides. So these halides have negatively charged and these halides have electron rich centers. Then hydroxide, alkoxide and carboxylate ion. In these ions, oxygen has electron rich site, that is oxygen has unshared pair of electrons. Similarly, in cyanide, nitrogen has unshared pair of electrons, so that is electron rich center. Hence, these species are called nucleophile. Now we are going to discuss about electrophiles. So electrophiles are reagent that are attracts towards negative charge or electron rich center. That means, so electrophiles are attracted by electron rich center or that is nucleophile, negatively charged nucleophiles. Okay, so electrophiles either positively charged species or neutral electrophiles, neutral molecules electrophiles. Okay, so in general electrophiles are electron deficient. Okay, all Lewis acids act as electrophiles and neutral molecules such as stannous chloride can also act as electrophile as it has vacant d orbital which can accommodate electrons from others. Because so Lewis acids Lewis acids are electron deficient which accepts electron pair, and here stannum has a d orbital which accepts electron pair. Okay, now we are going to discuss about neutral electrophiles. So first one carbon dioxide and dichlorocarbene. The formula is CCl2. Carbon has unshared pair of electrons. So in this, carbon requires electron density, that is carbon is an electron deficient molecule. Okay, and aluminum chloride boron trifluoride, and ferric chloride. So these are all called neutral neutral electrophiles, because in these species or these molecules, the metals are electron deficient. For example, aluminum, boron, and iron. These three elements or three metals are electron deficient, so these molecules are neutral electrophiles. So these molecules act as Lewis acid. And positively charged electrophiles, carbocations in general are plus. So C plus, it having positive charge on carbon, and proton H plus also electron deficient. And alkyl halide, here halogens have, that is halide have positively charged. And nitrosonium ion NO plus, here oxygen has electron deficient center. And nitronium ion, that is NO2 plus, here nitrogen is electron deficient entity. Okay, so these are described as electrophiles, that is neutral electrophiles and positively charged electrophiles. Okay, so in general, nucleophiles are electron rich center, whereas electrophiles are electron deficient center. Okay, and nucleophiles has two types. One is neutral nucleophiles and negatively charged nucleophiles. Similarly, electrophiles are classified into neutral electrophiles and positively charged electrophiles. Okay, in our next class we are going to discuss about inductive effect, electromeric effect, resonance, and all we are going to discuss. Okay students, thank you.